My name is Lasse Hässler, and can I take a look at that? Yes.
Yeah, you can.
Thank you.
Want it bigger?
No, I would
Like
need it
that?
smaller because I can so I can adjust, so I can see.
Like that.
Yeah, and how do I think? I guess not. Yeah. First, I'm going to tell you a little bit about prototypes. I do love prototypes. I've been prototyping all my life. You know, I guess it started when my father, he had in the cellar he had a workshop with a lathe and a milling machine. It was making live steam engines, and we had in the garden we had a railway, so he could build these small things. So, and then I started to building bikes and then mopeds and motorbikes and hot rods and things like that. So I'm building stuff all my life, and I do love it. I guess it's more started to be more real when I started here in KTH and was building doing wind tunnel testing. I was building models for wind tunnels. It was prototype airplanes and so on. So, and then I worked there a couple of years, and then I went to the US and then worked with a prototype airplane for 95 to 96. And then I came home and started my own business as a one-man show and work for artists and do art for artists and work with designer and make prototypes with designers and engineers and so on. And I can show you a little bit later on about what I've done. I have later on after this is done. And then 2013 I started at Prototal and as a boss there, and now we're I'm going here to talk to you a little bit about prototyping. And this is just a brief summary about me, what I've done. And I think one of the things that a lot of people do wrong is that, as the guy said before, that you should do more prototypes. It's because, and at least keep it simple. I mean, start with just sketches, pens, tape, MDF boards, anything. Just make 10 prototypes, and then I think after you've done that a while, I mean, it's so easy to get. No, but I don't have an image. I've just I'm trying to be free here somehow. I don't know. Yeah. It's so easy to get into the CAD and sitting and work with some corners or some surfaces that doesn't match really. It's so hard to let go of the keyboard. Or if you're doing programming, I guess you also need to sometimes release from the keyboard and do some. It's not working perfect, the code, but at least let it go. I think that's one of the things that people are doing. So simplify it. I think that would be very, very much to do it. And then I think you should.
Lasse?
Yeah.
Just a quick interruption.
Yep.
Just take the mic a little closer.
Okay. Okay. Try this. And then what you should do is also think about what should your prototype do. What is it for? What's the purpose of the prototype? Is it for being in a show? Is it for rough sketches? And think really hard. What is the prototype for? It's so easy to as I said, make it complicated. Do separate prototypes for machines with moving parts or rough sketches and so on. So do think like, what is it for? Is it for a mock-up with just so you know the volume, or is it a mock-up with the lines, with the color and the graphics, or is it a mechanical prototype for the mechanical solutions, or is it a Kickstarter mock-up or a prototype that you need for the Kickstarter when you think about how it should look and where you can film it and so on, or is it a thing that you have on a fair to show your product, So that's one of the things that you really need to think about before you start prototyping. What is it for? And then what I normally do is I print things. I love to print things. At home I have a MakerBot, an old one that I rebuilt it for chocolate printing, for instance, or I try what do you call it, ginger, printing gingerbreads. Yeah. So you can do whatever you want to with this thing. But I think one of the things that you should just think about. I'm going to go through three different kinds of prototype printing machines. Is this FDM that you have here in the back, which is like the caviar type that you press the plastic through and you make your stuff. And I do really like these ones. They're not so good if you're going to make high standard, high quality models, but it's as good at least, and it's good for you having in your small shop and doing things. So that's really, really good. It's not so good if you want to paint or do things like that. That's bad. Yeah, not so good at it. And then I have my favorite is the SLS printer. It's then you take a powder and then you have a laser that melts your part in that a layer that you want it, and then you take the next layer of powder and then you melt it and so on, and you continue doing that. I like that because then you don't have any support structure. You don't need any support at all. You can just rinse it away, the support, or not, I should say, you can just rinse the powder away. So you can make canals for cables or whatever you want to do. It's kind of good because then you can also do the thinking of this thing. Because if you do the FDM thing, then you need to, when you work with it, then you need to think, how is this going to be with the support? Where am I going to split the model and so on? And if you do the SLS, you don't have to think about that at all. You can just work with it as you want to, actually. And SLS is quite good. You can have glass fiber in it, so glass fiber reinforced, and you can actually print carbon fiber reinforced and other types. But it's not as many material as they have in like an Ultimaker and other ones. So, and then you have the SLA, which is epoxy. Liquid epoxy, which you harden with a laser beam, which works as similar as everyone. Harden one layer with a laser beam, and then you lower it down, and then you harden the next layer, and so on. That one I like when you should make a really, really crisp model. You should be a super tight model for a show, for instance. So that's I think it's the most accurate, and it's also cheaper if you want to make a good model to make it out of that, because it takes the model itself to print it is more money, but it takes less effort to make it a really, really nice prototype. And then I guess I should talk a little bit about milling. Milling, what I do when I do prototype, I do mill things in polyurethane, this foam, and it could be either the density of 0.2 to, I don't know, 7, 0.7 or something like that. Sometimes, a little bit higher. It depends on what kind of model it is. But that's kind of good if you want to have a big and a quick model to prototype to build up. So I do like that too in this case. And then you have casting, and I'm not so good in casting. So Pelle, please come here and show me. That's my colleague at Prototal. So he's going to come here and talk a little about casting.
Thank you, Lars. Hi, I'm the boring guy. Casting is actually what you probably will reach to last when you're working with prototypes. And casting is made in polyurethane.
Okay, so.
Sorry. So you first make a master in printing, and you can give it the finish you want to, and then you cast it in silicone, and then you use injection molding or polyurethane pure, and by that you can simulate very much the materials you can't print in. If you want a specific rubbery type or a specific shore value, it might be very difficult to do it in printing, because you have a limited number of materials you can emulate. In this type of casting, you can emulate almost every material, ABS or anything, and you can make good value with a pretty limited budget. You can make up to 20-25 casings, for example, for your gadgets. We're looking for armbands with, for example, dealing with people. So they wanted a soft material, and we looked into that. but it has some limitations, of course, for durability over the time. It doesn't last as long as a injection molded part. But this is something we look into after a while. Maybe we start with it during the work with the prototype, because people want to tend to know when will we be able to get to a pre-production model, to get out to maybe 10 or 15 shops or to different fairs or anything like that. So it's good to know the time span it takes to get a model in this technique. So I would say probably 3 weeks from start to finishing goods in your hand. Then also we would like to look into in real injection molding. Many prototypes are of course intended to be a product that will be sold in hundreds and thousands. And instead of making a tool with maybe 8 or 12 cavities, it's very good to make a small, simple aluminum tool first. Just one cavity to look to the product that it really works as you want it to, because to make any alterations in a 12 cavity tool made in steel is quite expensive. So it's often cheaper to make a fast little aluminum tool, make the device in the right material, everything works as it should be, and you can even make maybe a production of a small aluminum tool up to 20,000 parts. So it's a good way to really try out the market before you make the really big investment in a major tool that might cost you up to 1 million crowns or even more if it's a big part. A small aluminum tool that size might be around 35,000 crowns. So also that's something to be good to have in the back of your head, because it will take 6, 8, 10 weeks maybe to get that part in your hand. So that's also a good way to start before you want it, because otherwise you have to be on hold for another 10 weeks until you get the stuff in your hand. To coordinate everything in prototyping and put it into the market, it's very good to work on parallel tracks at the same time, so you don't have to put them one after the other, because it will take a very long time. And that's the process I'm mostly involved in at Prototal.
Yeah, thank you very much, and I'm done. We have some parts back there that you can come and look at, and I will show you a little bit what I've been doing when I'm working with artists and so on. So that's more private down there. So come and join me. Thank you.